Hello everyone, welcome back to Checkmate Scholars. In today's video, we'll be going over the 2025 6th grade math STAAR test. Make sure to check the link in the description to sign up for your free 1 hour of tutoring. Also check the description if you'd like to find the link to the previous released STAAR tests. Alright, let's get into today's video. Alright, question number 1 reads, in Mr. Jefferson's class, 35% of the students play a sport after school. Which decimal represents 35%? All right, we're going from percent to decimal. This is a very easy strategy that you can learn for your STAAR test. All right, whenever you have a percentage, all right, just like this, you're going to be moving your percent sign 2 places to the left. 1, 2. And that's where your decimal is going to go. So 35% is going to be the same as 0.35, which means C is our correct answer. But I want to prepare you in case you see some other types of percents and decimals. All right. So first, we're going to be looking at if our percentage sign already comes with a decimal. So let's say we had 35.5%. All right, what do we do here? All right, here's the little difference. You are not going to move your percent sign. No, you're not going to do that. Instead, you're going to be moving your decimal. All right, we're going to move that 1, 2 places to the left. All right, and I'm going to explain why there's that difference in a second. So here our decimal or our number is going to be 0.355. All right. So why do we do it this way? Let me show you. The logic behind this strategy is this. When you have 35%, I want you to imagine that your percentage, right, actually comes with a decimal. It comes with an imaginary one, okay? So 35.0%. So if this explanation helps you, you can actually do this whenever you're converting percents to decimals. 35.0%. Here, we're just gonna move our decimal 2 places to the left, all right? And so for some people, this is easier to remember, all right? So it ends up becoming 0.35%, all right? So a trick you can do, right, if you just want to remember one thing, is going to be to convert every single one of your percents into a decimal, all right? So let's say someone gives you 27%, all right? Don't just leave it there. Add your decimal point and your imaginary 0. Okay, and then you're gonna move your decimal 2 places to the left, and so this ends up becoming 0.27. But if we go back to our example where we had 35.5%, then there's no need to create an imaginary decimal. You already have your decimal. So in this case, we're just gonna move it 2 places to the left, creating 0.355. All right, now what if we are turning our decimals into percentages? All right, in this case, you're just going to be doing the exact opposite. All right, let's take answer choice B for instance. We have 0.035. In that case, all you're going to do is bring your decimal 2 places to the right. So in this case, our decimal is going to end up right here. So that means we're going to have 3.5%. Okay, 3.5%. And it works well because if we want to turn 3.5% back into a decimal, all right, we already know what to do. 3.5%. We already have our decimal, so we don't need to create an imaginary decimal, right? So we're just going to move it to the left 2 times. 1, 2. We don't have anything here, so we're going to put a 0 as a placeholder. And then we end up getting 0. So our decimal is going to here go right there, 0.035. All right. So that's the relationship between decimals and percentages. All right, let's take a look at question number 2. It says the manager of a pet store monitors the number of fish added to or removed from a tank each day over a 7-day period. Each number in the list represents the change in the number of fish in the tank for a day during that week. What number represents the total change in the number of fish in the tank? All right, so in this situation, we're asked to find the total change. All right, the total change. So that means we need to basically combine all of these numbers to see what the total change is. All right, so this is a fairly simple question where all we're doing is adding and subtracting. So we can start off with our first two numbers. We have positive 8. So that means they probably started off with 0. So they started off with 0, then they got plus 8. So at this point, we are at 8. Okay, so we have 8. Then we get to day 2, right? We have 8 minus 6, which is 2. Then we get to day 3, so we're at 2. Then we have another 2, so 2 plus 2 is 4. Then they lost some fish. 4 minus 5 is negative 1. They lost some fish again. Negative 1 minus 1 is negative 2. They gained some fish. Negative 2 plus 3 is plus 1. All right, so negative 2 plus 3, we have positive 1. Then on the last day, they get to minus 6. So 1 minus 6 is minus 5. All right, so the total change is going to be A minus 5. Question number 3. A school counselor sorts 875 students into 35 classrooms with the same number of students in each classroom. Which rate best represents the relationship between the number of students and the number of classrooms? All right, so we have a question asking us about a rate. Well, what is a rate? As it says here in the question, it's a relationship between two values. In this case, it's going to be the number of students and the number of classrooms. Now, looking at our answer choices, we have 2 that seem similar and the other 2 that seem similar as well. We have A and B, which puts classrooms per student, and we have C and D, which puts students per classroom. Now, which one makes the most sense? Obviously, the students per classroom, right? You can't necessarily put 25 classrooms to 1 student. No, we put students in classrooms. All right, and even if we look at the description for our question, we see the same relationship. We see that the school counselor wants to sort 875 students into 35 classrooms with the same number of students in each classroom. That phrase is very significant. It means that we're putting students in classrooms. We're not assigning classrooms to students. All right, so it's like saying I have 10 apples. All right, I have 10 apples. I always like putting things into simple terms. I have 10 apples and I have 2 grocery bags. I have 2 grocery bags and I want to split everything evenly. Do I give 1 grocery, or do I assign apples to the grocery bags or grocery bags to the apples? I can't say I want to give each apple a grocery bag, right? Because there's not enough. There's not enough, right? If I say it's 1 grocery bag per apple, that won't be enough, right? But if I reverse that statement and say I want to put apples in the grocery bags, right? Then we can split this evenly and we can put this group of apples into 1 grocery bag and this group of apples into another grocery bag, all right? So that's the same concept we see here. Obviously, we can't draw out 875 students because we don't have that luxury of time on our STAAR test. But what we do see is that we are dividing the number of students by the number of classrooms. All right. So automatically we can eliminate answer choices A and B, because I'm not going to give 35 classrooms to one student or 25 classrooms to one student, right? The question is telling us we are putting the same number of students in each classroom. All right. So now let's look at answer choices C and D. We have 25 students per classroom or 35 students per classroom. This is basically a division problem. All right, so we need to find out how many students can go into each classroom evenly. All right, so let's start off with 875, right? And this is basically a long division question. So 875 divided by, let's try 35, because we have 35 classrooms, right? So 35 can't go into 8, so that's going to be a 0. Use multiply and subtract. We get 8, bring down to 7. 35 goes into 87 how many times? That'll be 2 times. 2 times 35 is 70. Subtract, we get 1 and 7, bring down to 5. All right, how many times can 35 go into 175? Let's try 5. We multiply 35 by 5, what do we get? 5 times 5 is 25. 5 times 3 is 15, plus 2 is 7. So we get 175. So that means our answer choice, or our correct answer, is 25 students per classroom, which means answer choice C is correct. Question number 4. Which inequality is true for all values of n where n is less than -3? All right. When n, or where n, is less than -3, what does that mean? That means that we need to choose a value for n that is less than -3, so it cannot be greater than -3. For questions like this, don't hesitate to make a number line. Do not hesitate to make a number line. So in the middle we have our 0, right? And we have -3 somewhere around here. All right, so that means n has to be values that go to the left. All right, so -4, right, -5, and so on. All right, so from -4 all the way to -infinity, those are values we can use. We cannot use -2 or -1 or 0 or +1, because those numbers are greater than -3. All right, so now that we understand this, let's pick a number that we can plug in. See, whenever you're dealing with variables, don't hesitate to plug in a value or a number. You can use a number, all right, to visualize the equation or inequality you're working with. So in this inequality, I'm going to choose -4, all right? It's a pretty simple number that we can use. So -4 fulfills our first requirement where n is less than -3. Now we want to see which inequality works with that rule or with the number we chose. So let's try answer choice A. A says n plus 5 is less than -6. So where we see n, we're going to plug in -4. -4 plus 5 is less than -6. All right, -4 plus 5. -4 plus 5. How do we solve that? Whenever you're working with negatives, feel free to flop or switch them around. So -4 plus 5 is the same thing as +5 minus 4. All I did was switch them around. That's all I did. So +5 minus 4. What's 5 minus 4? 5 minus 4 is 1. So is 1 less than -6? No. All right, we have a positive 1 and we have a negative 6. All right, so here's where it helps to draw out your number line. All right, we have positive 1, which is probably on this side. We have 0, and then all the way on this side we have negative 6. Negative 6 is smaller than 1. Therefore, 1 is not less than negative 6. So A is not the correct answer. All right, A is not the correct answer. So we could X that out. Let's try B. Wherever we see N, we're going to plug in negative 4. Negative 4 plus 5 is greater than 3. Let's try it out. Negative 4 plus 5. Again, how do we do that? We can switch these around, okay? Or you can draw it out on a number line. So you have negative 4 right here, and then just count 5 spaces. All right, count 5 spaces. So this would be negative 3, negative 2, negative 1, 0, positive 1. So see, we still got to the same number, just as when we flipped around our numbers right here in our subtraction problem. So always you want to get very comfortable dealing with integers, negative numbers, positive numbers. You want to get very comfortable with them. So here we see negative 4 plus 5 is positive 1. Is 1 greater than 3? No, 1 is less than 3. Therefore, answer choice B is incorrect. All right, let's move on to answer choice C. We have N, which is negative 4, plus 5 is less than negative 1. Negative 4 plus 5, as we've seen, is going to give us a positive 1. 1 is less than negative 1. Is that a true statement? No. If we draw out our number line, negative 1 is going to be right here. Then we have 0. Then we have positive 1. All right. Negative 1 is less than positive 1. So answer choice C is therefore incorrect. All right. That leaves us with answer choice D. Now, some people like to just go ahead and bubble that in because it's the only option left, but I always like to encourage you to solve every single answer choice. All right, negative 4 plus 5 is less than 3. Negative 4 plus 5 we said is 1. Is 1 less than 3? Yes, it is. Therefore, D is the correct answer choice. If you're interested in a free 1-hour tutoring session with Checkmate Scholars, make sure to click the link in the description. That link will send you to a Google document where you can sign up for your student. All right, let's get back to the video. Let's dive into question number 5. It says, determine whether each statement describes a characteristic of a debit card or a credit card. All right, what's the key difference first between a debit and a credit card? A debit card is going to take money from your bank account. Let's say you have $1,000 in your bank account. You have $1,000 in your bank account and you want to buy something that is worth $450. Well, you can take out of your bank account, right? You can get that money and buy whatever you want. You can buy whatever you want. You're not going to be charged interest. You're not going to be penalized. This is your money. Now, the only thing is, once you've used up all of the $1,000, then there's nothing else left you can use for spending. All right. So that brings us to a credit card. What happens if we've blown our $1,000 on games, candy, and pizza, which is probably not the best idea. But let's say we have used up all of our money. Then you can use what is called a credit card. So it's this card. Let me just put a C on it. All right, so we have a credit card. This is basically access to someone else's money. All right. Now, because you're using someone else's money, they're going to charge you interest on it. So let's say I borrow or I use my credit card to buy something worth $450. Interest is going to be charged on that. Let's say it's 10%. So apart from having to pay back the $450, I'm also going to have to add back $45 with it. Why? Well, the $450 I borrowed originally was someone else's money. Plus, they could have used that money for something else that they wanted to use. So interest is kind of just like a way of saying, hey, thank you for letting me use your money. All right. So that's interest. You can also see each purchase or use of a credit card as a loan. All right. So what does this mean? Just because you use the $450 doesn't mean that's it. Remember, you're still going to have to return it back. Okay. You're still going to have to pay it back plus interest sometimes. So you're still going to have to pay these things back to the original owner. All right. And another characteristic is that sometimes when you use a credit card, you build a credit history. What does that mean? Let's say Johnny decides to borrow $450, but he doesn't pay it back on time. That is going to go into his credit history. Why? So the next time Johnny wants to borrow $450, there's going to be a little bit of suspicion like, hey, Johnny, are you going to pay my money back? All right, so that's the purpose of a credit history. It makes sure that the person who is borrowing the money is trustable or reliable and that that person will pay the money back. So now let's take a look at our answers or our answer choices. The first statement says it builds credit history, which can positively affect a person's credit score. That is going to be a credit card. Remember, whenever you use a credit card, your credit history is always going to be there. That's going to tell creditors, the people that give you the money or borrow you the money, whether or not you repay the money on time, whether you just don't pay at all, or if you're a person that is reliable and pays the money back on time. The second statement says the money used to purchase an item is automatically withdrawn from a bank account. That is a debit card. Remember, in the first scenario I mentioned, you have $1,000 and you can use that and withdraw it from your bank account, right? There's no type of interest charged. The only thing is just that once that $1,000 is finished, then you have nothing else left to use. And in that case, you would end up using a credit card thereafter. But to withdraw from a bank account is going to be using a debit card. Let's look at the third statement. Each purchase is a loan and will need to be paid back in the future. That is a credit card. Remember, you are borrowing someone else's money, so you have to give back what you've been borrowed. That is not a debit card. A debit card, you can use your money at your own will and you don't have to pay yourself back. All right. Last statement, consumers may be charged interest on their purchases. That is a credit card. Remember, sometimes when you use a credit card, you may be charged interest. Okay. Interest is simply a way of saying, hey, thank you for letting me use your money. All right. So that's the difference between a debit and credit card. All right. Question 6 says a floor is made of green tiles and blue tiles. The ratio of green tiles to blue tiles is 7:13. The floor has a total of 3,000 tiles. How many of the floor tiles are blue? All right. Let's take a look at this question. So we have a ratio of green tiles to blue tiles, which is 7:13. Okay. 7:13. So we need to keep this ratio in mind. That means for every 7 green tiles, I'll label it as green, we have 13 blue tiles, okay? So the ratio of green to blue is 7:13. So if I double this amount, right? If I double the 7 green tiles to 14, that means my ratio would go to, it'll still say the same, but the numbers would just increase. So we'd end up with 14 to double the 13, right? That will get us 26. 14 to 26, all right? So that is how ratios work, okay? If you do something to one side, you have to do it to the other side. Typically, it's either multiplying or dividing, all right? So if I multiply, let's say I multiply the number of blue tiles by 3, okay? If I multiply the total number of blue tiles by 3, I end up with 39 blue tiles. but whatever I do to one side, I have to do to the other side. So 7 times 3 is 21. So for every 39 blue tiles, I'll have 21 green tiles. Okay. Now the question asks us how many of the floor tiles are blue. Now what are we given? The floor has a total of 3,000 tiles. So we're not given the total number of green or blue tiles, but we are given the total number of both of those combined. Whenever you are presented with a situation like this, we're going to create a new ratio. Okay, so we've been given the total, right? We've been given the total, and we're asked to find blue. Okay, so how do we find that? Well, we know that our ratio includes 13 blue tiles. But what about the total number of tiles? That's where we can add these two numbers right here. 7 plus 13 is going to give us 20. So that means for every 13 blue tiles, there is a total of 20 tiles. Okay? All right. So for every blue tile, every 13 blue tiles, we have a total of 20 tiles. Does that make sense? Yes, it does. Because see right here in our original ratio, let's say we just had one set of this, right? One set. If we have 13 blue tiles on the floor, we're going to have 7 green tiles. And if we count up everything, it's 20. And this ratio continues to increase. All right, so let's say we had 2 sets of our ratio. So we have 26 blue tiles. Remember, if we multiply the blue tiles times 2, we have to do the same thing to the green tiles. 7 times 2 is 14, right? 14. So now if we add up this total, 6 plus 4 is 10. 2, 1 and 1, we have 40. And if you notice, 40 is a multiple of 20. So that's how we know that our ratio works. All right. That's how we know that our ratio works. So we have a new ratio of 20 to 13. 20 represents the total, 13 represents the blue. So now we're going to be able to use this new ratio to calculate how many of the floor tiles are blue. So when dealing with ratios, I like to line them up. So we have the total, okay? We have the total, and then we have blue. We have blue. Total to blue, all right? So let's line them up. For every 20 total tiles, we have how many blue tiles? We have 13 blue tiles. Now, what are we given? Our question gave us 3,000 total tiles. 3,000. All right. Now we need to find out how many blue tiles we have. We need to find out how many blue tiles we have. So how do we do this? How do we find this out? Well, we can do something which is called the butterfly method. This is a method that I love to use for questions like this. All right, so this is definitely something you would call a multi-step problem. All right, so in the butterfly method, what we do is we take the diagonals. So we're going to do this. These two numbers we're going to multiply, and then we're going to divide by 20, and that's going to get us our answer. So we're going to multiply 3,000 times 13. All right, 3,000 times my times symbol is so messy. 3,000 times 13. All right, so we get 0, 0, 0. 3 times 3 is 9. Then we get, leave our little space holder there. We have 0, 0, 0. 1 times 3 is 3. So we end up getting 0, 0, 0, 9, 3. All right, so we end up getting 39,000. So let me rewrite that so we can continue our next step. So we get 39,000. 39,000. 39,000. All right, now that we've multiplied our 3,000 times 13, we're now going to divide by our 20. All right, so we're going to divide by 20. 39,000 divided by 20 is going to get us 1,950. All right, 1,950. So A is going to be our correct answer. All right, let's take a look at question number 7. It says the Venn diagram shows the relationship between three sets of numbers. So we have our rational numbers, we have our integers, and we have our whole numbers. Which value would not be located in the shaded region of the diagram? All right, so the shaded region represents integers, but let's first look at all of our other categories. So we have whole numbers. Whole numbers are going to be your numbers going from 0 all the way to infinity. All right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity. Remember, it includes 0. Your integers are going to be your number line numbers from negative infinity all the way to positive infinity. All right, so negative 4,000, positive 500, 0, everything included from this number line. Okay, it's going to be included. The only thing with integers is that you're not going to have any decimals or fractions. So you're not going to have 8.3 or negative 5.2. All right, now there is an exception with the fraction. If the fraction can be reduced or simplified to a whole number, then it can fit. So 10 over 2 can be simplified to 5, and 5 is a number that can fit on the number line. But if I have something like 10 over 3, right? If I try and simplify that, that'll be 3 1/3, right? That cannot be an integer because it's still a fraction. So the only rule with fractions and integers is that the fraction has to be able to be reduced or simplified into a whole number. Okay, let's check out rational numbers. Rational numbers are going to be all of the numbers that are left out. These are going to be your fractions that can't be simplified or repeating decimals. So if I have a number that has a repeating decimal, right, something like this, that can fit as a rational number, right? Because I can express this as 3 1/3. It can still be expressed as a fraction. All right, so rational numbers, right, you're gonna have basically everything within it. Okay, so you're gonna have your integers as part of your rational numbers, your whole numbers, plus everything that can be a fraction. Okay, everything that can be represented as a fraction. So it's going to also include your fractions and your repeating decimals. All right, it's going to include your repeating decimals. So keep that into mind. Those are your rational numbers. Here's a bonus tip. Your irrational numbers, I'll say IR, irrational numbers are going to be all your numbers that are not repeating decimals. Okay, so these are numbers that cannot be expressed as fractions. All right, that is the main definition of an irrational number. So if we take pi, for instance, 3.14, and it keeps going, we can't put that into a fraction. All right, or the square root of 2 or the square root of 10. We can't represent these numbers as fractions, okay, because they have decimals that don't repeat, but they go on infinitely. So the difference between repeating decimals is that they repeat. Let's say something like 9.4545, repeating. Pi, on the other hand, does not repeat. It just goes on forever, different numbers. So that's the main difference. So now let's check out our question. So let's start off with answer choice A. Does this fit into the shaded region? -8/2 can be simplified into -4. So yes, it does fit. So A is not our right answer. -33, that fits on the number line. That's not the right answer. 11/8, that cannot be simplified into a regular number, a whole number. So 11/8 is going to end up giving us some type of decimal. So 11/8 is a rational number, not an integer. So this is probably our correct answer. What about 2? 2 fits on the number line, so 2 is not it. So therefore, correct answer is C, 11/8. All right, everyone, that brings us to the end of today's video. If you found it useful, I'd really appreciate if you could give this video a like. Also, maybe share it to a student that could maybe benefit from this type of content. Remember, in the future, we are going to other grade levels for STAAR test prep, so make sure to subscribe so you're updated when we do release those videos. Also, if you'd like one-on-one tutoring for your student, don't forget to check the link in the description. There you can access the sign-up link for Checkmate Scholars. Remember, for new Checkmate Scholars customers, you do get 1 hour of free tutoring, so don't let that opportunity pass you by. Sign up today. As always, I'll see you in the next video. Until then, checkmate.